Hello everyone, this is your very first flipped classroom video for Algebra 2. We are starting in the unit called quadratics, and this is day 1, so you probably want to write quadratics at the top of your page and then put day 1 up there. Alright, we're going to start, I'm going to try to start all the videos with some fun facts. Do not write these down, they are just things to get your brain going. Alright, so the Beatles actually showed their support for the U.S. Civil Rights Movement by refusing to play in concerts where audiences were segregated. Another fun fact is that researchers have found that the music one listens to can temporarily change a person's perception and affect what they think and see. So when you're sitting there listening to your music, it can actually change what you're thinking and seeing. And finally, another fun fact is that the man who invented pop-up ads has apologized to the world for creating one of the internet's most hated forms of advertising. Alright, now on to some math. In this PowerPoint and video, we are going to have some I can statements. Alright, we have a few here. The first one is we're going to graph quadratic functions. We're going to identify the key characteristics of a quadratic, and then finally we're going to use a graph to solve a quadratic. Okay? So first, before we can do any of those things, we have to figure out what is a quadratic. A quadratic is a function whose degree is 2. This means that 2 is the largest exponent, and when they graph, it makes a parabola. Well, there's probably some words in here that you're a little confused about. So here's an example. If you look at this equation, the highest exponent in the equation is a 2. It doesn't matter that there's a 4 as a coefficient, or 3 or the 2. The only thing we're worried about, what makes it a quadratic, is the 2 that's the exponent, and it's the highest exponent. Alright, and so what is a parabola? Well, this is a parabola. This is the graph of that equation that's been graphed. It makes what looks kind of like a U, but we're going to use the word parabola, and the parabola can be right side up or upside down, and we'll talk about that a little later. Okay. So, how would I graph a quadratic? With any function you're given, you can always graph it by making a t-chart. So if I gave you this equation, f of x, and f of x just means the y part, f of x equals x squared plus x minus 6. So how would I even begin to graph that? So making a t-chart, x is on one side, y on the other side. So what would happen if I plugged a bunch of numbers in for the x value? So I'm just going to use these numbers. You can use any numbers you want to, but some numbers you wouldn't want to use, like 235. That would be ridiculous. So go ahead and put this t-chart on your paper. We're going to do -3 to 3. So what would happen if you actually took the number -3 and you put it in both the x spots? Well, you would get 0. Why do I get 0? Because -3 squared plus -3 minus minus 6 gives me 0. Then you would continue on this process. You would plug in -2. When you plug in -2 to all the x spots, you end up with -4. So on and so forth, and you would end up with -6 for -1, 0 for -6, 1 for -4 for 1, 0 for 2, and 6 for 3. So now I'm going to have to take these, this is nothing but a set of coordinate points, and I'm going to set these coordinate points and I'm going to put them from the t-chart onto a graph. Okay? So that's the same equation I was using. This is the same t-chart from the previous slide, so you don't have to write any of that. Now, what I've done is taken each one of these points, A, B, C, D, E, F, and I have plotted them on this coordinate point. I did not do the last one, 3, 6, because it would be way up here, probably where where it says quadratic at the top of the slide. Okay, so I just cut that point off, which is fine because I have my overall shape. I don't have to do all the points that I come up with. Okay. So if you see A is the point where you go, x is -3, so you go over to -3 spot, and then you go, the y value is the 0, so that's why I went up 0. When you connect those points, they make a parabola. Okay? So that's one way to graph quadratics, is to use a t-chart. Alright, so what are some key terms or characteristics that I'm going to need to know about parabolas? I need to know that real roots, also called real solutions, are where the graph touches the x-axis. The x-axis is the one that goes left to right. This can happen at 2 spots. It can hit it at 2 spots like the previous equation. It can hit it at 1 spot, which means it bounces off the x-axis, or You could have a graph that never touches the x-axis, so therefore it doesn't have any real roots or real solutions. Okay. Another word you're going to need to know is vertex. It's also called the maximum or the minimum of the quadratic. This is the lowest or highest point of a parabola. It's where the parabola goes from increasing to decreasing or decreasing to increasing. So it's the center of your graph. Okay. And the last word you're going to need to know right now is concave up, and where it bends upward, that would be a right side up view, or concave down, where it's bending downwards. This refers to the direction of the ends of the parabola. So if it's going up forever and ever, it's concave up. If it's going down forever and ever, it's concave down. All right. So let's do an example problem. Can you describe this graph? So this is just a graph of a parabola. What can you say about this graph? Alright, so here are just some things that I could say about this graph. I could say it's concave down because it's a downward U, it's a downward parabola. Okay, it also has a maximum. If it's concave down, it has a maximum because it has a highest point at negative 3, 1. So if you were to plot the point negative 3, 1, it would be at the top of that parabola. Okay, I could also say it has real roots because it touches the x-axis, so it has real roots at negative 2 and 0. Negative 2, 0, and negative 4, 0. This is also known as the x-intercepts. It's intercepting the x-axis. Okay, so I could say these are x-intercepts, or I could say they're where the real roots of the function are. Okay. Finally, I could say that the solution to the quadratic that makes this parabola is negative 2 and negative 4, because that again is where it's touching the x-axis. All right, we're going to do some more of these in class. Make sure you bring your notes so I can give you your credit for doing this assignment. And you have now completed the first day of your flipped classroom. See you in class.